Hi, I am Varun Joshi and welcome to the fifth lecture in our Argo CD Basics to Production course. In this lecture, we focus on Argo CD projects, a concept that fundamentally changes how Argo CD is used in real production environments. Until now, we have relied on the default project. Today, we will see why that approach doesn't scale and how projects introduce governance, guardrails, and clear ownership boundaries. We will understand what an Argo CD project really is, how it differs from Kubernetes namespaces, and how it controls source repositories, deployment destinations, allowed resource types, and GitOps level RBAC, all enforced before the sync even begins. We will then walk through a hands on demo using a single fictitious application called Application 1, composed of front-end tier and a backend tier. Essentially, we'll be deploying a two-tier application using Argo CD. We will create an app project for this application, deploy both tiers within its boundaries, and intentionally violate rules to prove these guardrails are real and enforced. By the end of this lecture, you should have a production ready mental model of how Argo CD projects enable safe, scalable GitOps. So let's get started. Now, before I start, if you see that hype button, I would request you to hype this video. Secondly, 50% of the audience that watches my channel, they are not subscribed. I would request you to please subscribe to this channel if you are finding value here. I am creating high value content for free. I hope you will understand the time and efforts it takes to make this kind of content. So if you are liking these videos, subscribe to the channel, like the video, comment how you feel about the videos. It would really mean a lot to me. And lastly, I have also opened memberships in this channel. If you want to contribute further, then please do become a member. So let's start with this lecture. Why Argo CD projects? Firstly, I want you to know that we have been using Argo CD projects since the inception of this course. Why, Varun? So firstly, if you see, we have always defined this project as a default. Now, this default project is available to you by default. It does not have all the bells and whistles that Argo CD projects have to offer. So keep that understanding in mind before we start discussing why Argo CD projects. So first bullet is unrestricted source repository. So right now, whatever Argo CD applications that we are creating, we are free to use any source repository, and that's a security risk because I do not want my DevOps engineers or my developers to be creating Argo CD applications that are using unauthorized source repositories, because I, as an administrator, clearly know that the config repository for, let's say, this microservice or this tier or this application is located in this repository. Hence, I must only allow those source repositories. And it is not just from a security perspective. I also want you to think of this as a guardrail perspective. Maybe I, as a DevOps engineer, was doing an all-nighter, and today by mistake I added something in the source which should not have been added. Maybe my personal repository, maybe my forked repository. I don't want whatever manifests are there in those repositories to be deployed into my cluster. Hence, we must have means in place via which we can control what can be defined in the source repository section. And then the second one is uncontrolled deployment destinations. And this makes sense. I want my Argo CD application to be only be able to deploy resources onto a cluster for which that application is authorized. I don't want my engineers to mistakenly deploy onto clusters which do not have to run those applications. And I want you to know one thing very clearly. You could be dealing with 10-15 clusters, and you are deploying onto those 10-15 clusters using a single Argo CD instance. In that scenario, this becomes extremely critical. Maybe the application YAML that I have created must deploy into cluster 1, but what if by mistake my engineer added cluster 2 here? If I do not have guardrails in place, then this kind of mistakes will continue to happen. And I, as a DevOps engineer or as a DevOps lead, must be ensuring that both mistakes, genuine mistakes, and attacks can be prohibited. And these things can only be prohibited if you are adhering to principle of least privilege. Hence, both in source and destination, I should have proper guardrails in place so that only allowed repos are used, and the destinations must also be clearly defined. Now, I want you to know that right now we are saying that this is the application, deploy this in this cluster and use this source repo to check for your manifest. But when we are using projects in a proper way, then we will have means to define that only these source repos are allowed and these destinations are allowed. Third is no resource level safety. Let's see one thing. I will go to my terminal and I'll run my favorite command, kubectl API resources. Now, this will give me all the resources available at my disposal, be it custom resources or be it normal native Kubernetes resources. Why I am bringing this up? For example, if my application just requires two manifests, and these two manifests are one a deployment YAML and another a service YAML, should I allow my Argo CD instance to deploy anything other than these two? Doesn't make sense, right? I have so many resources at my disposal, but if I know my application just needs two of them, let's say deployment and service, then why would I allow rest of these? With this application manifest, I do not have means via which I can be strict that when someone uses this application, Argo CD can only deploy a deployment and a manifest. That's all. It should not be allowed to deploy a config map. It should not be allowed to deploy an ingress and rest of the resources. It should only be allowed to deploy a deployment and a service. That is what we lagged. We did not have means to define that here. Next one is missing application level RBAC. Now, let's first understand why this is my favorite command. So if I run up arrow and here is my kubectl API resources and I add -o wide, I can see that what all are the verbs that are supported by, let's say, a resource. So for example, if I talk about daemon set, then all these verbs you can use to allow different users. So if you give get permissions, then that user or that group can only run get commands. So this will also give you verbs. But why I am discussing this right now? So this point says missing application level RBAC. Now understand, I as Kubernetes administrator, if I run this command again, but this time what I want to also do is I want to grep -i argo. I just want to list Argo CD resources. Now what I can do as Kubernetes administrator is I can give certain admins access on applications, on application sets and app projects as well. So these are the verbs that are available at my disposal, and we have seen this extensively in the CK code. So if you have any confusions about this, you can watch authorization, cluster roles, cluster role bindings, and that lecture will give you more clarity on how to use these verbs. But for now, I want you to understand that these verbs are talking about these resources, okay? But they are not talking about Argo CD specific nitties and gritties, such as I cannot disallow a user to perform the sync operation in Argo CD UI. So once you have this application, you can run sync apps, you can run a refresh, you can run prune, you can run so many things that are related to Argo CD. But you cannot use Kubernetes RBAC for that. You can use Kubernetes RBAC to allow or disallow users to create applications, create application sets, create app projects, and so on. But when it comes to performing sync operations, prune, and so many other things that Argo CD has to offer, you cannot use Kubernetes RBAC for that. But what is the solution for that? There must be something within Argo CD that will allow us application level RBAC. So when we just use applications with the default project, we do not have that functionality. Last one is single tenant trust model. All applications share identical permissions. Now let's say you have 50 Argo CD applications, and if all of these are using the default project, then you have no segregation based on criticality. There is no governance, there is no security, and so on. Now, what is that thing that takes care of all these challenges? And here I welcome the Argo CD project. So Argo CD project define hard GitOps boundaries that every Argo CD application must satisfy before sync begins. And this is the critical piece here. Before sync begins. So before synchronizing anything, Argo CD application must ensure that the things that are defined in the Argo CD project are being adhered to, and only when those things are adhered, the application is deployed. So let's first understand what we had before. So if I move here, this is the default Argo CD project that we have been dealing with thus far. So what it is automatic fallback used when no project is specified, fully permissive by design. Now what I mean by permissive is there are no guardrails in place, everything is allowed. So it is fully permissive, good for learning only, suitable for demos and quick experiments, which we have been doing thus far. Then unsafe for production, and we know why it is unsafe, because there is no isolation, no governance, or blast radius control. So with this understanding that what are default projects, let's see when we are leveraging custom projects what all we can do. So let me just balance this out first. Now let's first see what are these three snips. Now first snip is of an app project, and app project is what defines a project. So if I go here to my terminal, and if I just run this command again, kubectl API resources, I'll just remove -o from here. So when I installed Argo CD, 3 custom resource definitions were installed, and applications we have already seen, and today we'll be discussing app project. So understand that we will be writing app project YAMLs. Hence, they also need to be version controlled. Like we saw in our previous lecture, we version controlled our applications YAML. Similarly, we will be version controlling our app projects YAML. So anything that is declarative, we typically version control it. And so app project will also be version controlled. So like you see here, here is an example of this sample YAML. Now, we will be doing this deep dive in our demo section. For now, what I want you to understand is here is an app project YAML whose name is application1 project, And if you see, both of these are applications. These applications are my backend and my front end. So what I'm trying to convey you here, folks, is my application at large is called application 1, and that application 1 has a front end and a backend. So what we discussed in past lectures is essentially you would have different architectures. So in this section, we are dealing with tiers, app tier and a web tier, also called front end and a back end. Hence, I will have two different Argo CD applications for this, which is why you see I have two different application YAMLs. Now, what is the difference? In the project section, it is referencing a specific project that we have created, and this one is referencing this app project. And if you see the source repos, I'm saying anyone who references this app project or this project can only supply the names of these two repos. Hence, if I supply anything else in the source, then this will error out. So this has given me governance on what can be defined in the source repos section. Similarly, the destination here can only be this, and that is why in our application manifest, we can only define this as destination. Now, there are other controls which we will see as we will progress from this point. First point is GitOps Guardrails enforces boundaries beyond simple application grouping. Now, I want you to know that this is not just application grouping. Of course, what we are doing is we are doing some sort of grouping here, but that grouping is not just a simple grouping. It is there to enforce boundaries, to have controls in place. Second is governance abstraction, defines and enforces application level permissions such as trusted source repositories, deployment destinations. We have already discussed this. Allowed Kubernetes resource kinds. So when I talk about resources in Kubernetes, they can be either namespace scoped or they can be cluster scoped. And we'll be diving into this concept as we progress with this demo. So for now, just understand you can define what are the things that are whitelisted. Like I talked in the previous section, I said if your application just uses deployments and services, then only allow that. And that is exactly what we are doing in this YAML. So we are allowing creation of 4 kinds of objects or resources: deployment, service, config map, and secret. See the kind here, and we'll be dissecting this. So allowed Kubernetes resources kind, application level RBAC. That snip I have not shown here, but when we move to the demo, we will see how application level RBAC works, organization and multi-tenancy, and we'll be dissecting all these points in the demo. So I believe you have a fair understanding of what Argo CD projects are. With that understanding, let's move to the demo. So I will scroll down. The demo is working with AppProject, two-tier application, from GitOps Guardrails to enforced application state. So in this demo, we'll be dealing with a two-tier application, and that application will have a front end and it will have a backend. So if you see, the step 1 is repository layout and creation. We understand that there must be separate repositories for our code and config. In this step, we will dissecting this point in detail. Second is we'll be creating a namespace. Understand, for now, we will be manually creating the namespaces. As we progress with this course, we will learn about sync waves, hooks, and so on. At that stage, we will be creating namespaces using YAML. Now, why this is important? Understand, when you create resources, you would want a certain order. For example, you would want the namespace to be created first and then the resources that will be deployed onto that namespace. So there must be some means via which you can define a sequence. So we have not studied that part yet, which is why we'll be creating this namespace manually. Step 3 is the most interesting piece. We will be creating this app project YAML. We will be understanding each field in detail. Step 4 is we'll be creating Argo CD applications, and exactly like this we'll be creating two applications, one for the front end and the second one for backend. And then step 5 is build and push container images. In this step we will be building a container image and pushing it onto Docker Hub. I want you to know that in the previous lecture where we discussed about private repositories and also about private image registries, we used everything private. But in this lecture, for simplicity, I would be using public image registry and public repos. And in this step itself, we will understand the application code. So what is the front end code? What is the backend code? Step 6 is where we'll be populating our config repositories with our manifests. Then in step 7, we'll be verifying whether everything is deployed by Argo CD. Understand that we will be using features like automated sync, pruning, and self-healing, which is why as soon as the connection with the repositories is established by Argo CD, we will see that the resources have been deployed. In step 8, we will be accessing our application using port forwarding. And finally, in the step 9, we will be doing some sort of chaos engineering to prove that the guardrails and RBACs are enforced properly. Now, before I move on with the demo, I want to show you the prereqs for this one. So I'll go to my GitHub page, and then here I will go to Argo CD basics to production. And then here is this lecture's notes, and then I will scroll down, and from here I will go to prerequisites for this demo. Understand that you should have an Argo CD instance up and running, and it should be port forwarding. So for me, the port forwarding is already working. So if you see here, port forwarding is working. And then if I go to my browser, I have already logged in into my Argo CD instance. So this should already be in place. Now let's start discussing about the first step, repository layout and creation. So in this step, we'll be creating our repositories and we'll be understanding the structure. Now we clearly know that the application code repo and the config repos are separate. It's a best practice to have these things separate. But if I talk about my front end and back end tier, you can have different repository designs. So I want to take a moment to tell you what all options are available at your disposal. So if you look at this chart, let me scroll down, maybe my face is interrupting your view. And here you can either have two repositories, and when you have two repositories, one will be holding the application one code, and this implies there will be two subdirectories created, one for front end and one for backend. And similarly in repo 2 as well, application 1 config repo, you will have two directories created, one for front end and one for backend for separation. And we have talked about this in detail if I go to lecture 2 and lecture 3. So if you do not have that understanding, I would encourage you to go and watch those lectures. So this design is used by small to mid-sized organizations. It is most common there. Shared life cycle for front end and back end, minimal ownership and governance boundaries. And that is obvious. You are using essentially a mono repo design, which is not recommended when you are dealing with production grade implementation. And then there is a 3 repository design. What you will have is you will have 3 repositories. Repo 1 will have application front-end code, repo 2 will have application backend code, and then there will be a third repo which will have app1 config. And this repo, the third repo, will now have two directories, one for front-end and one for backend. That is how you will be segregating resources if you go with 3 repo design. Now I want you to know that when I talk about the code repo will also hold your Docker file along with your Jenkins file or your build spec.yaml or any YAML that pertains to your CI/CD tool. So keep that thing in mind. And you may also see this design being used when I talk about the recommended design. So this is the recommendation when you are dealing with enterprise grade applications. You have 5 repositories, but Varun, why 5? 4 I can understand, 2 for app code front end and back end, and 2 for config front end and back end. What is the 5th repo doing here? I want you to clearly know, to whom does this app project YAML belong? This belongs to application 1 as a whole. It does not belong to backend or front end. So where do you store your project YAMLs? So you create another repository where your this YAML will be stored. Project YAML will be stored. So that is what the 5th repo is doing, used by large enterprises, regulated environments, strong separation of duties, smallest blast radius per change. Argo CD platform config is what we'll be calling this repo. It defines global GitOps guardrails, access and onboarding for all applications. Now, as we progress with this lecture, we will learn what all other manifests can be stored in this Argo CD platform config. For now, we will just be storing our project YAML. Now what I will do is I will go to my GitHub and I will start creating my repository. So from here, I'll go to the top and then I'll open this in a new tab. And here I will go to repositories and then I will click on new. And here I will be creating my first repo that is named app1 frontend config. So I'm creating the config related repositories. For frontend, I have created. For backend, I will create next. So I'll click on create a repository and then I will create one for backend as well. So I'll go here and then here I will go to repositories, new, and then I will paste that here. App1, this is for backend. Previously, what we created was for frontend, and this will be public. That's correct. I'll click on create repository. Now let's also create a third repository. And this repository I am creating for my Argo CD project YAML. And this one I will call Argo CD platform config. And you will see what other things we can store in this as we progress with this course. So we have created 3 public repositories. Now understand, when you are dealing with production implementations, these will be private, like we saw in our previous lecture. For simplicity, I am showing these as public. And I want you to know that right now I am not creating any repositories for my application code. So when we are dealing with production implementations, you have CI servers. In those scenarios, you will have these code repos as well. I will just be creating, container images and then pushing them. I don't want my code to be in repository. But if I talk about production designs, you will have 2 more repos here as well. Now that we have this understanding, we have the repos created. Next, I want to create a namespace. So I'll go to my terminal and then I will go to this tab here. I will run kubectl create ns app1 ns. I'll be creating a namespace where we'll be deploying both the tiers of application 1. I'll press enter and this says that the namespace is created. Now let's see what we want to do in step 3. In step 3, we want to create our project YAML. So let's go to Visual Studio Code now. Now, when you go to the GitHub repository for this lecture, you will find that I have defined the entire structure for you You can download this and go hands-on along with me itself. So I will first open Argo CD platform config. This is where my project YAML resides. So I will zoom in a little and then I will give you a walkthrough of this line by line. So first is API version, and we know all of these things can be understood from this kubectl API resources command. So if you run this command, you will know what is this API version, and you will also know what is the kind. So since we are dealing with AppProject, you can see this and this from here. And these are the short names for AppProjects. We'll be using this as we progress. Then metadata. So we are calling this app1 project. Namespace is Argo CD. We know that whenever you are creating resources associated with Argo CD like these three, you will be creating them in the Argo CD namespace itself, which is why I have defined Argo CD namespace. Under the spec section, we have description first. Project for app1 frontend and backend workloads. Understand that when you are in production implementations, having detailed description is important, so have something meaningful here. Source repos. I have defined two repos here, and both these repos we just created. So if I go to the browser and you see front end, this is the URL for the front end, and if I go to backend, this is the URL for backend, and I have defined these in the source repos. Now anyone who is referencing this project, any application that is referencing this project, can only use these two repos. Destinations. Now destinations, I have namespace is app1. Anything starting with app1 is permitted, and I'm defining that the destination can only be this cluster. So whatever applications will be using this app project can only deploy to this Kubernetes cluster in this specific namespace. So app1 and then hyphen and then a wildcard. See, at this stage itself, I want you to broaden your imagination. So right now, I am creating this project for app1. Okay, but understand, I could also be creating a project for anything development, and I can call that dev project, and based on that dev project I can have source repos, namespaces, and all these things defined. Do not restrict yourself from thinking that this project must be application specific. So if you understand why projects are used to begin with, then you can create that mental picture in your head. So if I create, let's say, a dev project here, then any applications who are referencing this dev project can be using any of the repositories that I define here, and all the destinations that I define here. Maybe in that scenario, I will have dev and then a star. So anything that starts with dev, resources can be deployed onto that namespace. So broaden your imagination. Okay. Then next is cluster resource whitelist, and then you have namespace resource whitelist. And if I run that command again, if I go to my terminal and I run kubectl API resources, then we know that there are certain resources that are namespaced, and then there are certain resources that are not namespaced. So namespaced resources are essentially the resources that you deploy onto a namespace, and the resources that are cluster scoped, as in non-namespaced resources, are the resources that span the entire clusters. For example, if I talk about ingress classes, they span across the cluster. And if I talk about ingress, they are limited to a namespace. And similarly, you can check about deployments, services, and so on. All these are namespaced. But when I talk about persistent volumes are cluster scoped, but persistent volume claims are namespace scoped. So you have to understand these things. Only then you can be writing these things in your YAML. So here what I am saying is, when I talk about cluster scoped resources, only whitelist namespaces. now what does this mean? Now let's say if any of these repos have a namespace YAML, the namespace can be created because I have allowed that, I have whitelisted that. But if user tries to have any other manifest here for the cluster scoped resource, for example, if I talk about, let's say, persistent volumes, okay, persistent volumes are cluster scoped. If someone tries to create a persistent volume, then I won't allow that to be created, because what I have done is I have only allowed namespaces when it comes to cluster resource whitelist. Understand this point, it is critical to understand this. Now when you allow a certain resource, then there is an implicit deny. So if you have allowed namespaces, then any other cluster scoped resource will not be allowed. Then second is namespace scoped. So here we are saying namespace resource whitelist. So anything that is namespace scoped and you want to allow, you allow in this block. So in here, anyone who is trying to create a resource that is outside of that list, so any manifests that are held here in these two repos should only be these. If there are any other manifests, for example manifests that are creating persistent volumes or persistent volume claims, then those things will be denied. So only these things are allowed. Then I have deliberately added this block here, cluster resource blacklist, although these things are disallowed by default because there is an implicit deny after this. So once you have allowed something, once you have whitelisted something, there is an implicit deny that follows. So I didn't have to have this block. I have kept this block so that you can understand it. Now Varun, what is the group and then what is the kind? Kind you already understand. Kind is this kind. Okay. So when I talk about deployment, I am allowing deployments to be created, which is why I have, the kind deployment allowed. So if I scroll down, where is deployment? Yeah. So if you see this, I am allowing this. But what about this group here? So this has apps, this has blank. Now what Kubernetes has done is they have segregated the resources based on their API versions. This can be thought of as a grouping. So when I talk about anything that has a v1 here, that belongs to the traditional API group. And when we are dealing with app version v1, then you do not have to supply anything inside double quotes. And if you have good understanding of cluster role bindings, role and role bindings, then you will understand this point in a much better way, because there as well we use something similar to this. Again, if I talk about deployment is under the apps API group. So if I go to deployment here, if I scroll down, you see this is part of the apps group, which is why we have apps written here. Similarly, if I talk about RBAC cluster role and cluster role bindings, if I scroll down, you will see cluster role and cluster role bindings. Here are the role bindings, here are cluster roles and cluster role bindings, and you see these are part of RBAC authorization k8s.io, which is why you see here RBAC authorization k8s.io. So I hope these things make sense, and if you have okay knowledge of Kubernetes, you would already know these concepts. Then let's talk about the interesting piece. Here we have roles. Now what are these roles? So we are saying we are creating two roles. We are naming them dev read only role and platform admin role, and then we are defining a description for each of these. We are saying that anyone who is part of the group app1 devs can use this role. Anyone who is part of platform team group can use platform admin role. So this thing is obvious and can be easily understood from this YAML itself. But Varun, what is this? So for this, let's go to our GitHub notes. I'll go here, I'll go to this one, and then I'll go to scroll down, and I want to go to create app project guardrail, and I'll scroll down. So the description of this YAML is also here if you are interested in reading. I'll scroll down further down, and here is the syntax for this. And it is very simple. And once you start using this, you will have an understanding of this very clearly. So I've opened the reference as well, the official documentation for this. And this, you can refer this one. So the syntax is P role, user, or group, then you enter a resource. Now what is this resource? This resource can be applications, application sets, clusters, projects, and so on. In our example, if you see here, we are talking about applications, which is why we have applications here. As we progress with this lecture, this course, we will see more things that can be used. So let's do one thing. Let's walk this from left to right. So I'll go here, and then let's match this one by one. So we are saying the syntax is P. So this P is here. Then role, user, group. So here we are saying we are talking about a project. That project is app1 project. And why we are calling app1 project? Because we have named our project app1 project. And then what we are saying, platform admin. So platform admin is the name of the role. So we are discussing this, hence we are calling this. The name is platform admin. And then we are saying applications. So the resource that we are dealing with is applications in this scenario. Then you have actions. Actions is applications is fine. You are allowing things to be done in applications. But what things are allowed? What are the verbs that are allowed? So here I'm saying anything is allowed. So this can be view, sync, update, delete, rollback. All of these things are allowed. But when I talk about this role, dev read only, this one is saying allow users in the dev read only role to view, that is read only, all Argo CD applications within the app1 project. Then in this one, what I am saying is allow users in platform admin role to perform all Argo CD application operations. All. And what are those operations? What those operations could be: view, sync, update, delete, rollback, prune, etc. And why do I know this? Because this is already there in the documentation. So if I go here, what it is saying, get, create, update, delete, sync, and based on what resource you are using. So I am using applications right now, which is why I can leverage all of these. So invoke is not available here. So for example, now I want to give you one more direction here. So Argo CD is a GitOps controller. It is not something that will manage your users for you. Of course, you can create local users, but in production, you will rarely be using such kind of approach. What you would be doing is you would be integrating your Argo CD with your SSO. For example, so if I go to the documentation itself, and if you see here in the user management section, you can integrate Argo CD with Okta, OneLogin, Google, even AWS's IAM Identity Center, which was formerly known as AWS SSO. So once you integrate with these solutions, all the groups that you create in these respective identity providers, Argo CD will work on that premise. So for example, let's say you are using Microsoft's Active Directory. In that scenario, you would first create a platform team group in Microsoft Active Directory, and then you will be adding users to this group. For example, a DevOps administrator would be part of, let's say Varun is the name. So Varun will be part of the platform team group. And once Varun is added, then Varun will have these level of permissions when I talk about applications that are referencing app1 project. So I hope you have this solid clarity. With this understanding, let's apply this manifest. So what I will do is I will walk you through the structure later, but for now I will right click here. I'll click on open integrated terminal, and here I will write kubectl apply -f, and I only have one file here, app1proj.yaml. I'll press enter and it says the project is created. I want you to notice one thing very clearly, that I first created a project and only then I will be creating my Argo CD applications. Then that is understood. Until and unless the project is created which is referenced by my applications, it wouldn't make sense. Hence, you first create your project and then you move to creating your applications. So what I will now quickly do is I will use that terminal only to see my resources. I will run kubectl get app projects and -n argo cd, and this will tell me that you have app1 project and you have the default project. App1 project was created 46 seconds back. So if I go to my browser now and I go here and I go to settings and then I go to projects, you see the default project had asterisk everywhere. So it was allowing everything, which is why I said this project is fully permissive in nature. But when I talk about the project that we recently created, you can see whatever we defined in the YAML, all of those things are available here. So you can check this via the UI, or you can check this via the CLI using the describe parameter. So if I run describe here, then it will show me all the details about this application project. So we have this clear understanding. Now with this, let's move to the next step, which is step 4, and let's see what we want to do there. I'll go to my diagrams, and step 4 is create Argo CD applications, front end and back end. And it is exactly like we saw before. So what I'm doing is I'm expanding the app1 backend config, and in app1 backend config I have two directories. Understand that one that is called Argo has my application manifest, the Argo CD application. And then if I talk about backend, this has my Kubernetes manifest. Understand what we learned. You separate your application code repository and your config repository. The code repository for backend is this one. Right now, I want to concentrate on the config repository, and we learned that the config repository will also have your Argo CD application along with your manifest. Now, I have segregated these into directories for better readability, and I'm calling this backend. You would see this also called manifest, or whatever your chief engineer or your application architect or your DevOps architect decided the nomenclature to be. But understand, these nomenclatures must be self-explanatory so that anyone who is working, even if you leave the organization, can see and understand what this previous engineer was trying to do, and he or she should have a smile that this person did things how they are supposed to be done. So this terminal I can exit, and now what I want to do is I want to open a terminal in this Argo directory. So I'll click on open integrated terminal here. Understand where I am. I will run kubectl apply -f. I only have one file here, app1 backend application crd. And if I apply that, it will say created. And we have already seen these, but I will again give you a short walkthrough of this. So I'll click here and then let's see what is going on. So here this part is understood. Application metadata app1 backend app. I'm calling this so that as soon as I see this application, I know this belongs to application 1 and this is for backend, and I have that app so that I know via the naming as well that this is an Argo CD application. Naming is important. Namespace is Argo CD. We understand why this is Argo CD, because Argo CD related resources should be created in the Argo CD namespace. In the spec section, I have project, and here I'm referencing the app1 project that I just created. So what I will do is I will open these things side by side so that I can show you these things in a better way. So I'll open this in the right, I'll split this to the right, and then I will close this from here, and then I will also minimize this one here. Maybe let me just zoom out a little. And then I'm saying the source repo to be used is this one, app1 backend config. And why I can freely use this? Because in my app project YAML, I have allowed this. Target revision is head. This will point to the latest commit in the, in the default branch, and the default branch in our case is main. Path is backend. Now, what I'm saying, in this repository, the things that you have to apply, the manifests that you have to apply are there in the backend directory. And that is what the structure that we have defined. In backend config repository, we will have these things in the backend directory. And that is what we'll be doing. We'll be uploading these soon to our GitHub repository. I'll minimize this, and then destination is already understood. Sync policy, we are saying we will be using automated sync. Prune is true, which implies if something is deleted from the repository, then you delete it from the current state as well. Self-healing states, if someone creates a new resource or modifies any resource in the current state, then delete that resource, because our desired state must always match the current state. So if you do any modifications in the current state and the desired state does not depict that, then the current state will be modified to adhere to the desired state. So I hope this is clear. Now I will close this YAML. I'll close this too. And then let me just quickly reopen this so that we don't commit any mistake here. I will right click here, open in integrated terminal, kubectl apply -f. I'll apply this YAML. And this is already applied. I think I applied it before, and along with you itself. And then if I go here to this application for front end, let's apply the front end application as well. So if I go to app1 front end, it has the similar structure, Argo and backend. Here we have Argo and front end. If I expand Argo, you see app1 front end application YAML here. So I will right click here, open in integrated terminal, and here as well I will run kubectl apply -f and then name of that YAML. So I want you to see that this is also similar, if not same. It is just that in place of backend we have front end, and path as well is front end. So if I go to my UI now, if I go here and if I go to applications, I see that both of these applications are created. Now I want you to clearly know that the status is showing healthy for both of these, the application health status, which is wrong. And of course, this is because we have not performed a sync yet. That's why it is showing healthy status. This is not the actual healthy status. So it will show unhealthy when the sync has been performed once. Right now, it does not have any real information because it cannot connect to a repository. Or can it? It can connect to your repository, but your repository does not have anything yet. So if I click on this error, it is saying fail to load target state, fail to generate manifest from source 1 of 1, unknown description, fail to list references, remote repository is empty. So it is saying I'm able to connect, but your repository is blank, my friend. Then what is that I should be doing? So let's upload our repository with the files that are needed. So if I go to my draw.io, so we have done this, So before uploading anything, let's first build and push our container image. But before we even do that, let's understand our application code. So I will go to my Visual Studio Code again. I will exit this so that we have more real estate. Exit this too. And then I will close this. I will minimize everything and then reopen. So let's run tree instead. That would be better for your understanding. I'll write tree here, and you see I have 5 directories, and like I said, you will be creating 5 repositories in production implementations for this kind of application. Now, application 1 backend and application 1 frontend, these two are my code repository. So this has the data that should be uploaded in the code repository. Now what this has my application code for frontend. This has the application code for my backend. And similarly, if I talk about config repos, the Argo directory has my application YAMLs, the Argo application YAMLs, and backend and frontend, these have the respective frontend and backend YAML. So we are just creating a deployment and a service. All these YAMLs are here. So now we have this understanding. Let's see the application code. So I'll go to Visual Studio Code. I will expand application 1 backend. Let's first study the backend. And if I open this, this is just saying that hello from backend API. That's it. And this is listening on port 5000. Okay, this is backend. So if I go to the Docker file here, we are saying that use this as the base image. Working directory is /app. We install Flask because our application uses the Flask framework. Then we are saying copy app.py, which is this one, to the /app. That is our working directory. Then this is just for information. We are saying our backend listens on port 5000. Understand, this is just for documentation. Actually opening the port is part of the application code. So here we are saying our application listens on port 5000. And then Docker file, we are just running the application by running python app.py. So that is our backend code. So we'll be using this Docker file to build the container image. Now let's also see the Kubernetes deployment and service manifest for backend. So if I open this as well, if I go to deploy.yaml, then I would see that it's a very normal YAML. I am just calling this deployment backend. We are deploying this in app1 namespace, 1 replica. All of these things you already understand. But here is the key part. We are saying that the image that you should be using is this one. And this will make much more sense when we create our container image using the Docker file that you just saw. Ports, I am saying this listens on port 5000. And this is again just for information. Your application should indeed listen on this port for this to work. Then we have the service manifest. The service manifest is also simple. We are saying that the target port is 5000. This is the port on which my container is listening. And then the cluster IP port is also 5000. So this is our backend code and manifest. Let's talk about the front-end code and the manifest. The code again here is simple. It is trying to reach the backend URL and fetch the message that we showed there. So what we showed there was this one, right? We showed there that service backend hello from backend API status is success. And that is exactly what we are polling here. We are reaching our backend service and we are asking it to show that message. And then our front end service will also be saying front end. And you see we have defined certain variables here which will be calling our backend service URL. Now you see we have defined that here. We are saying whatever you want to fill here, get the details from backend SVC on port 5000. And we know backend SVC is this one, which is listening on port 5000. So this is a very simple application. I gave you a walkthrough so that you understand the application as well. Front-end deploy is simple. Here we are defining an environment variable. We are saying the value for backend URL is this one, and that is okay. Then we have service manifest. Here we are saying the target port is 4000. The 4000 is the port on which my application is listening. And why is that? Because if I go to the code, it is listening on port 4000, which is why if I go to service manifest or front end, the target port is 4000 and the cluster IP port is 80. So we have this understanding. Now let's do one thing. Let's create our container image. So I will again minimize everything. Then I'll go to 5 and then I will go to app1 backend and then right click here, open in integrated terminal. And here is where I will be creating my Docker image. So I will run docker build -t cloud with varjosh, that is my Docker Hub account name, and then I will write app1 backend, and then let's have a tag v1.0.0. So 1 is the major, 0 is the minor version, and 0 is the patch release. And then I'll add a dot for the context. I will press enter, and this has started building my container image. Now if I run docker images, then I would see that my image is created. App1 backend is created here. Now let's do one thing. Let's push this image. I'll run docker push, and then I will just copy this thing from here, and then I will paste it here, and I'll press enter. It directly pushed. It did not ask for any credentials because I am pushing into cloud with varjosh account. How can I push into an account without logging? I can, because if I go here, if I go to my dashboard of Docker desktop, then you see I've already logged in via my cloud with varjosh account. If you are using Docker engine in, let's say, Ubuntu or any Linux based VM, then what you should be doing is you should also perform a Docker login. Only then this will work. Docker push will work. And if you are using Docker desktop, just ensure that you are logged in. So I'll close this one, and this has pushed. So now what I want to do is I want to also push the front end. So let me copy that so that I can quickly type the commands. I'll copy this, and then I will go to app1 front end. I will open an integrated terminal, and then I will paste it here. And this time here I will write front end, and rest is okay. So I'll press enter, and this will build this for me as well. And I'll copy this, and then I will write docker push, and this will push into my Docker Hub account. So in the meantime, let's go and check my Docker Hub account, hub.docker.com. And you see app1 backend is already here, and my terminal is still pushing app1 frontend. Let this work. Let me try this again. Let me run Docker images, and I see app1 frontend is created. So let me just try to push it again. Docker push, and then it has copied the tag 2. I'll press enter. Oh, this says done. So let me go to my browser. I will hit refresh, and I see app1 frontend and backend are both here. So this is my private account that has 2 public repos here. These 2 are public repos. This one is a private repo. So that is why we do not have to supply any credentials. That is why in our deployment manifest, we are using these with just this information along with the tag. Now, if you want to see how this works in, let's say, when you have private repos, in that scenario, you should check the previous lecture. Now let's go to our draw.io and see what we want to do next. So this part is done. Populate config repositories. Now let's upload our content to our repository. So first, let's go to our Argo CD again. And here you see the status is still unknown and unknown because we do not have any files in our repositories. So let's go to backend first, and let's click on upload existing file. So I'll go to Finder. I will go to courses, and then Argo CD, then lecture 5, this one. And then this is for backend config. I will go here, and then I will move both of these here. And I'll do the same for the app1 front-end config. I'll go and click on upload existing file, and then I'll go to this again. I'll go to front-end config, and then I will drag these here. I'll do full screen here, and this has uploaded. I'll click on commit changes here as well. I'll click on commit changes. So both of these changes are committed. Now what we should see, Understand. Right now, it is unknown, unknown. If I go to my application CRDs, let me exit this. Let me exit this. If I go to my Argo CD application for backend, you see that I have sync enabled, automated sync enabled, prune and self-healing is also enabled. So ideally, if I go to my browser, then this, you see, this is now synced because we have automated sync enabled, and this was checking with my repository if there is something to be deployed, and it saw that the desired state that is defined in Git is not matching the current state, and hence it performed a sync. Now this is actually healthy. So if I click on, let's say, backend first, then you see there is a backend SVC, and then there is a backend deployment as well. So, and you see it is referencing a commit which ends with 01D. So if I go to backend, you see 01D was the commit that we did a minute ago. Now I want you to know one thing very clearly, that Argo CD checks your repository approximately every 3 minutes. Understand, it has synced automatically because we have enabled automated sync. If we didn't have that in place, if we didn't use this, let's say sync policy automated, then we would have to click on synchronize for this to synchronize. Okay, so the interval that is defined is for checking with the GitHub repository whether the sync will be performed automatically or not is governed by this. So I hope that distinction is there in your head already. So both front end and back end are deployed. So let's do one thing. I'll go to my terminal. I will clear my screen for more real estate. I will run kubectl get all -n app1ns, and you see the backend pod is running, the front end pod is running, the services are created, everything is hunky and dory. So let's do one thing. Let's access our application, and accessing our application is also our next step. That is step 8. So step 7 we have already done. Deployment and service are created for us. Now let's access our application, and to know that the name of the front end service is front end SVC. So what I will do is, here I am port forwarding for my Argo CD. Let me open another terminal. I will zoom in here. I will run kubectl port forward -n app1ns, and then the service there that I want to use is SVC, front end SVC, and I want this to listen on port 8081 on my local host, and the port to which I want to forward anything that comes on 8081 is, if I go here, it is port 80. That is the cluster IP port for my front end service. So I'll go here and I will write 80 here. I'll press enter, and this has started forwarding. You remember our application front end, the front end of our application 1 is listening on 4000. So if I go to my browser, if I type localhost 8080 and press enter, oh, 8080 is Argo CD, I'm so sorry, localhost 8081, press enter, hello from backend API. So this is what we were displaying, and the service that is displaying this is this one. The code that we had in our front end was hello from front end. So this was a very simple application. I hope all of these things are connected perfectly. Now let's verify whether whatever we have done, all the guardrails that we have implemented, are they working correctly or not. So if I go to, let's stay in this browser itself. So if I go here, rather let's go to Visual Studio Code. So if I come here, so what we have said is, when it comes to cluster resources, only namespaces are allowed to be created, and namespace resource whitelist, we only have these four objects that can be created, objects or resources. These four can be created. So as long as I'm creating these four, I should be okay. But if I create anything other than these, then I should not be okay. And same applies for cluster scoped resources as well. Only namespaces are allowed to be created. So let's do one thing. Let's try to create a namespace scoped resource and a cluster scoped resource. So I'll go to my browser. I will go to backend. Let's do this in backend. I'll go to this backend path, because understand that we have defined the path as backend. So I will click on add file here, and then let's do one thing. Add file, create a new file, and then I will name this pv-pvc.yaml. And here we'll add a pv YAML and a pvc YAML. So I will go to my GitHub repository for this course. I have a YAML there, a pv and pvc YAML. I'll scroll down and here it is. So here we are creating a persistent volume and then a persistent volume claim. So I'll copy this. I'll go to new file here. I'll paste this here, and then I will click on commit changes. And there is one more thing I want to highlight here. Now you would be thinking, Varun, if we do any changes in this manifest, then those changes will not be automatically applied by Argo CD, because Argo CD is just monitoring backend directory. And that question is correct, and we'll be answering that in our next lecture. So for now, this understanding is sufficient. So we have already created this YAML file. Now we understand that automated sync is enabled. Argo CD will be checking with our repository app1 backend config to see if there are any changes. As soon as it finds this, what Argo CD should be doing, it should see that what are the guardrails that are available in the project with which the application is associated with, and based on that it should take a decision. So if we go here, you see sync is okay. So let's do one thing. Let's wait, or we can also click on refresh. So for now, let's wait. What I can also do is I can manually click on refresh so that it checks with the repository if something has changed or not. But for now, let's wait for this to be automated. So it checks approximately every 3 minutes. You see, it automatically sets syncing, and then it says out of sync. And you see here, these things are green, but these things are yellow. And if I click on this syncing, read the message. Persistent volume is not permitted in project app1 project. Resource persistent volume claim is not permitted in project app1 project. And this is so interesting and so cool. Anyone who tries to create resources that we have not specifically allowed, then those things will not be allowed to be created. So we have understood this thing. What we can do is quickly we can go to this, and then we can go to this file, and then we can delete this file. I'll come here, and then let me delete this. Commit changes, commit, and this will delete this file so that this is again back in healthy state. So if I hit refresh, so let it work under the hood. We'll come back to this later. Now let's see what we want to do next. So what we have checked is we have checked these things. We have checked that if we are trying to do anything outside of this, it is not being allowed. Now I want to do something here. So as I told you, I do not have an integrated IDP where we can test this thoroughly, but what I can do is I can create a user locally and then see how it works. Understand, if I create a user locally, that user should not be allowed to see anything, because only users that are part of this group are allowed get access, and that too only on applications that are part of app1 project, that are referencing app1 project. So for now, let me go to the CLI, because if I go to this screen, I'll tell you one more thing. If I go to Chrome, and then if I go to a user info, I don't see a tab to create a user here. Okay, if I go to settings, even if I go to accounts, I don't see an option to create an account here. So we'll have to use the CLI. So I'll go to the CLI. I will run Argo CD account list, and this shows admin is true, capabilities is login. Now if I have to create an account, then what I can do is I can edit the Argo CD CM. So what I will do is kubectl edit CM -n Argo CD, and the config map that I want to edit is called Argo CD -cm. So this is what I want to edit. I'll press enter, and here in the data part, what I will do is my camera is obstructing my view. Hold on. So I will indent this properly, and then here I will write accounts.cwvj. What I am saying is I want to create a user that is called Cloud with Varjosh, or I want to create an account that is named CWVJ. And here I will write login. So what I'm telling here is the user that I create should have UI login privileges. And I want you to know one more thing. Right now we are using the admin user to log in and perform all those actions. If you want to disable that admin user, then you can remove this line as well. So I press escape shift ZZ, and the user is created. See, the user is created, but how about password? Because if you log in into the Argo CD UI, it always asks you for a password. So let's do one thing here. I will run an Argo CD command. I'll go to GitHub here, and then I will scroll further down. And this is how you create a password. So Argo CD account update, name of the account, CWVJ, that is what we just did. Current password, this password is for the admin user, anyone who is running the command. So I am running the command as admin user right now. And if you don't know how to log in as admin user, you go to Argo CD login and then supply the URL of your Argo CD instance. Understand that you could be having several Argo CD instances. On which Argo CD instance you want to run the commands. For that, you first run Argo CD login and then the cluster where you want to run the command. And once you press enter, it will ask you whether you want to proceed. Because we are using HTTP, then the username is admin, and then the password for my admin account is admin@123. Once you have added that, you will be running commands in that context in that cluster. So if I go here, then here I'm saying the current password for the user that is currently running commands is admin@123. The new password that I want to set for this user is cloud with varjosh@123. So I'll copy this one, I'll paste this here, I'll paste it, press enter, and then it says password updated. So if I go back to the UI, and then let me log this out, and let me run localhost 8080, I press enter, and now I will log in with cloud with Varjosh, and then password is cloud with Varjosh@123. And I don't see anything. I don't see anything because there are only two groups that are allowed to see what is there in the app1 project. What are the applications that are part of app1 project? And the user that we are currently using does not fall under any of these groups, which is why that user is not permitted to list our applications. I hope that makes sense to you. Now let's do one thing. I will now exit from here, log out from here, and then log in again, because our one thing is still pending, correct? Localhost 8080. Let's see what's with that sync status, admin@123. Sync failed. And then let's click here and see what is happening, why the sync failed. Okay, let's do one thing. Revision. Let's do one thing. Let's refresh this. If I refresh this, so it is not giving any problems here. Those yellow highlighted PV and PVCs are now gone. But here it says sync failed for 89C. Now let's see why this failed. 89C. So I deleted that as part of this commit. So history is this. and we added that as part of 89C. So it has not read this commit yet. So hold on, let me see why this is. Argo CD refresh. Let me manually try to synchronize this. Synchronize. Oh, it worked now, and it is now reading the latest commit. And if I go here, what was the latest commit? It is F90. And if I come here, it is F90. I hope this connected a lot of the dots for you. Now, if you want to practice anything else, what you can do is you can try to create an Argo CD application that uses any other repository than this and also points to this project. So try doing that. That should not work if you are pointing to any repositories other than these two. That brings us to the end of this lecture. You should now have a clear understanding of why Argo CD projects are essential for production GitOps and how they enforce boundaries around where applications can deploy, what they can deploy, and who is allowed to operate them. We validated these concepts hands-on by applying AppProject, deploying applications within its constraints, and intentionally triggering failures to observe policy and RBAC enforcement in action. This lecture lays the groundwork for what comes next. In the upcoming lectures, we will build on the same setup to explore orchestration concepts like sync waves, hooks, and ordering, and see how Argo CD scales to complex multi application environments. If you have any questions, feel free to ask them in the comment section and I will reply. If this lecture helped, do consider liking, sharing, and subscribing. It really helps the channel. I will see you in the next lecture. Thank you very much.